Run an object detector on a photo of a single parked car, and you might be surprised by what actually comes back. Not one tidy box, but a messy pile of 20 overlapping boxes, all shouting the word car, each with its own confidence score. This isn't a bug. Detectors are built to fire many predictions around the same object, and that output is basically unusable because you can't even tell how many cars are really there. So nearly every classic detector ends its pipeline with a cleanup step called non-maximum suppression, or NMS for short. It's a simple, greedy rule that takes that noisy pile and turns it into exactly one crisp box per object. Let's walk through it and watch it work. NMS is a short, greedy loop, and once you follow it a single time, the logic feels obvious. Everything begins by sorting. Take all the candidate boxes the detector produced for one class and line them up by confidence, most confident at the top. Ordering by score is what makes the rest of the loop simple and fair. Then pick the winner. Grab the highest scoring box left in the list, accept it as a real detection, and set it aside as kept. This box is the detector's most confident guess, so it earns the object outright. Now comes the suppression, the step the method is named for. Compare that winner to every other box and drop the ones overlapping it too heavily, meaning their intersection over union with it exceeds a chosen threshold, say 0.5. High overlap is strong evidence these are just duplicates describing the same object, so away they go, cleared out of the running. Finally, you repeat. Move to the next highest surviving box, keep it, suppress its heavy overlaps, and loop until nothing remains. What falls out the other end is exactly one clean box sitting on each real object. So what does this actually buy you? Put the detector's raw output next to what NMS hands back. Raw detector output is a swarm. A single car can collect 20 near-identical boxes, all slightly shifted, all labeled car, all overlapping. Draw that on the image and you cannot even count objects because every real thing is buried under a cluster of duplicates. After NMS, the picture is clean. One confident box per object, duplicates gone, and the scene finally readable. Here's the thing, that clarity is why almost every detector you have heard of, from faster RCNN to YOLO to SSD, quietly ends its pipeline with this exact step. Now, 3 ideas carry the whole method. Get these and you understand both why NMS works and where it can bite you. First, always keep the highest confidence box. The greedy rule trusts the detector's own scores, letting the most confident prediction claim the object before anything else gets a say. That single choice anchors the entire loop. Second, suppress overlapping duplicates using IOU. Any box that overlaps the winner beyond the threshold is treated as the same object and removed. This is exactly where intersection over union does its second job, deciding what counts as a duplicate. Third, respect the threshold trade-off because it is where NMS gets delicate. Set it too high and near-duplicate boxes survive and clutter the result. Set it too low and you start deleting real neighbors, like 2 people standing shoulder to shoulder who each deserve their own box. That very tension inspired softer variants such as soft NMS, which gently decay the scores of overlapping boxes instead of deleting them outright. Alright, let's pin down what NMS really does inside a detector. Detectors fire many overlapping boxes per object, and NMS is the greedy cleanup that keeps just one. The loop sorts by confidence, keeps the top box, then drops every box whose IOU with it exceeds a threshold. That threshold trades duplicates against missed neighbors, which is why soft NMS decays scores rather than deleting. Nearly every classic detector, from faster RCNN to YOLO, ends with this exact step. For more computer vision essentials unpacked in plain language, head over to standarity.com and keep exploring.